what I'm going to introduce to you are index laws, which means that we shouldn't break these. These apply all the time. They're not like theories in science. These work all the time. They've been proven to work. So I'm going to give us, I'll get rid of that heading in the front. Can you please write these down just below where you've got question 4, index laws. And my first index law is multiplication. And that's where I'm going to have a to the power of m times a to the power of n. Who knows how to do that? Most of you are probably thinking, I've never seen a to the power of m. How do I solve that? Why have I used a, not a number?
It could be any the same number.
Can be any of the same number. Why have I used m? Could be any number. It doesn't have to be the same as a, does it? I'm just saying it could be any numbers. Underneath this, I'm going to give us an example. What numbers need to be the same here? The a's, correct? So I must have, give me an a value. Give me a value for a.
2.
2? Okay, give me an m value that's different to my a value. 3. Times, what must I have next? 2 to the power of? 6. Let's go 6. Okay. Now using this law, I'll be able to figure this out. Before we go any further on the law, what's this? Who got the answer to that? Who's got the answer? Ashton? Yeah, A. What's 2 to the power of 2? 2 times 2 is? Times 2 again? So we know that's 8. That equals 2 to the power of?
3.
Okay. I'm just going to do that one randomly. Randomly going to do that one first. I'm going to come back to my law now. What do you think my law is? I'm going to put a little 1 here as well. Why am I putting a 1 there? Because 2 by itself is 2 to the power of 1. Okay, interesting. So I've got my law a to the power of m times a to the power of n equals. Did this number change? Still the same, so it's going to be a to the power of. Give you 3 seconds to think. M plus n. And I'm going to put brackets around that. Why do I need to put brackets around that? Because I want that to happen first, don't I? And because it's a power, if I type a to the power of 3 plus 6 in my calculator, it's going to go 2 to the power of 3 and then add 6 to that. Because we've got bombouts, correct? So I need to put brackets in. So who can tell me what this is? I don't need to know what the final answer is, I just need to know what it is in index form. Yep, 2 to the power of 3 plus 6, which equals 2 to the power of 9. Awesome, that is the index law for multiplication. Guess what my next one's going to be? Division. I'll let you write that down, don't worry. Put that in? Yeah, write it down. Yep. I know this stuff, I've done it a couple of times. If I'm writing on the board, it's usually not for my pleasure. So I want you to think, if you've got that down, whilst we're going through, I'll give you the start. It is a to the power of m divide, what do you think it's going to be? A to the power of n, and that equals. See how that goes. We've got through that, we've had plenty of think time. Division, Ella. Well, why don't we look at B as an indication? Did you get an answer for B? What is it? What is it? We learned from our mistakes. Tell me. Have a guess then. Sam, what did you get for this? 3? Just 3? So that's like 3 to the power of 1? Okay. So when you got Ella, remember it? Good. So let's come back to this. We had 3 to the power of 3 divided by 3 to the power of 2, and that gave us 3 to the power of 1. So what do you reckon the rule is? The law. What do you reckon the law is?
It's just M space N.
Very good. So it's a to the power of m minus n. And in brackets again. Now I know that Yannick knew that. How did I know that? I knew before this moment that he knew that. How did I know? What question did I see that he'd done properly to know that he'd already knew that law? Is this question easy without that? I've told you no calculator, so it's impossible unless you know that law. So what's the answer to question C now? A to the power of 2. I just contradicted myself. I just said I wouldn't go for hands and look straight up the line for him. That's good, Harry. Sweet. Who feels a little bit better about how they're going with index laws now? Alright. There's one more index law. But I actually don't think we need this index law if we've got a bit of common sense. What does an index mean again? Repeated multiplication, correct? So am I within my rights? I'm just going to rub this one out. Am I breaking the rules of maths if I turn 2 to the power of 2 squared into 2 to the power of 2 times 2 to the power of 2? Am I allowed to do that? Is that the same thing or is it different? It's the same. So what's the answer to this? 2 to the power of? 4. What if instead of giving you a nice gentle one, so I'll go to a power, I'll put it down below, I'm running out of room, power, I've got a to the power of m to the power of n, and that equals, we'll just wait up. If I change this to 3, what would have to change?
The amount of 2 to the power of 2.
So I'd have to add one more, wouldn't I? So it now becomes times 2 to the power of 2. What would the answer to that be, Adam?
That would be 128.
I think you're right, actually. But I meant index form. That is very good, but in index form. I'm very impressed, but in index form. Would it be 2 to the power of?
2 to the power of 6.
Very good. 2 to the power of 6. So let's come back to our law now. What has Adam done? He's turned 2 to the power of 2 to the power of 3. What's happened? What do you reckon, Lockie? What's he done? A to the power of? M? What do you do at the end? Something n. What's the something? Who thinks it's at? Minus? Divide? Times? Good. It is a to the power of m times n. So that's all well and good. What do you think needs to happen once we've learned these new things, or we've been reminded of a few things that we might have learned in the past? What needs to happen? Am I good to just leave this line down and you're right to your final exam? All good? What should we be doing now?
Practice.
Bit of practice.